Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the second part of algebraic fractions, where we'll be looking at questions such as express as a single fraction. So, for example, we might have a variety of different operations in terms of maybe multiplication, adding, subtracting, division, and we're just literally asked to rewrite it in the form of a single fraction. So we'll start off with some more simpler questions, and then as we go through, they'll get progressively harder. So the first one we have express 4x minus 10 over 8 times 2 over 3x plus 6 as a single fraction and in its simplest form. So the first thing I'm going to do is not really worry about the fact that I need to express it as a single fraction. I'm just going to actually apply whatever operation is happening. In this case, it's multiply. With algebraic fractions questions like this, we also need to be really confident that we're happy with actually how fractions work in the first place. So, for example, do I remember how to multiply two fractions together? Because obviously this one we can't really put in the calculator. So multiplying fractions is actually quite easy. We just have to times across horizontally. So the two numerators you multiply, the two denominators I multiply. Obviously you might be happy to just multiply that directly, but I'm just going to write it out fully as it's going to be a set of single brackets just so you can really see it properly. And the denominator is 8 multiplied by 3x plus 6. Now I can literally expand out these brackets. So we get at the top 8x, then we get minus 20, and the bottom we get 24x, and then plus 48. Okay, so we have already obviously got it as a single fraction, but that's why they've also specified in the simplest form. I'm now going to look at this and see if I can simplify it. This is where you'll need to have seen the previous video in order to understand how to simplify algebraic fractions. What I'm looking for is, you see how I have four terms here? I've got 8x, minus 20, 24x, and 48. I need to find or see if there is a common factor between all four of those terms. Is there a number that I can divide all four of those terms by? And actually, yes, the highest common factor of all four would be 4. So I'm going to divide each of these four terms by 4. The other way that we did in the previous one was factorising out a 4. You could write it like this if you want. So I get 2x minus 5. And then at the bottom, if I factorise out 4, I get 6x plus 12. Now, you don't necessarily have to write it like that. You can just literally work out what it is without the 4s, but I'm just doing it to kind of over-explain it for you. And as you can see, I can then cross out both of the 4s. They cancel out. So there's my final answer, basically. We get 2x minus 5 at the top and 6x plus 12 at the bottom. It feels like I should be able to simplify it more, maybe by 2, but as you can see the 5, I can't divide 5 by 2. The other 3 terms I can, but not the 5, so therefore that's it. That's the most simplified I can get. I've got 2x minus 5 over 6x plus 12. So here I've kind of over-explained it by writing it out fully. You don't necessarily have to write down all of these steps, but do make sure you write down at least a little bit of working out so you get all the marks. Okay, the next question we now actually have add. So express 5 over 2x plus 1 over x plus 4 as a single fraction. Now adding fractions, again we need to remember how to add fractions, is a little bit more complicated because when we add two fractions they need to have a common denominator. And if you look at what we've got here, 2x and x plus 4, well that's clearly not the same thing, is it? So then you go, okay, yeah, I know I normally need to find a common denominator. But how do I do that when it's algebra, when I've got x's and pluses and minuses and so on? It definitely seems a lot more complicated, but actually, in this case, what I suggest is just multiplying these two together. For example, let's just say an example with numbers. If I add 5 as a denominator and 7, the lowest common multiple is just 5 times 7, isn't it, sometimes? So I'm just going to do that. If I've got an algebraic denominator where it's not very obvious what the lowest common multiple is, don't worry about that. Let's just multiply them both together to get a common denominator in the first place. So obviously we know with fractions, again, if you're going to change the bottom, you have to also change the top. So for example, for the 2x, I'm going to multiply it by x plus 4. Therefore, I also need to multiply the top by x plus 4 as well. Because then if I would simplify it, it would still be the same fraction, wouldn't it? Plus, the second fraction is already x plus 4, isn't it? I'm just going to write it over here. I need to multiply that one by 2x. So the numerator, I also need to times by 2x. Given that it's already 1, I'm just going to write 2x here. Again, if I were to cancel it out, I would get the same fraction left over. Now they have common denominators I can just add across in the numerator. So we've got 5 brackets x plus 4 plus 2x as the numerator over 2x brackets x plus 4 in the denominator. So I've expressed it as a single fraction. I'm now going to expand and simplify. The numerator I get 5x plus 20 plus the other 2x still over obviously 2x squared plus 8x. And then the numerator I'm going to collect the like terms. So I've got 7x plus 20 over 2x squared plus 8x. Now I can double check, can I simplify anything? Are there any common terms? Do they all have x's? No. Do they all have a number in common that I could divide by? Actually, no. So in this case, there's nothing to simplify further. I would leave it like this, or you can also leave the denominator factorised as well. Given that I can't cancel anything out, let's leave it factorised. So I'm just going to rewrite it with 2x, x plus 4. Either way, that's fine. The same also goes if you're subtracting as well. We need to find a common denominator, so just times by both denominators. Okay, this is very similar again, except now we also have x's in the numerators. So express 3x over x minus 2 plus 2x over x plus 1 as a single fraction. Again, I'm not going to mess around with thinking of what's the lowest common multiple. I'm just literally going to multiply together those two denominators and change the numerators to match. So the first fraction was 3x. I'm going to have to multiply that denominator by x plus 1. So I also have to multiply the numerator by x plus 1 as well. Whatever we do to the top of a fraction, we have to do the same to the bottom. Then plus, the second fraction was 2x already. That one was x plus 1. I'm going to multiply the top and the bottom by x minus 2. And then we can add and expand and simplify, basically. I'm just going to do this all in one step. So expanding, we've got 3x squared plus 3x, plus the second one is 2x squared minus 4x, all over x minus 2x plus 1. That's the same denominator. Now I'm just going to simplify, collect the like terms of the numerator. So we've got 5x squared there, minus x. I'm going to leave this one factorised. Now, can I simplify anything? Is there any common terms? Well, actually, no. I could factorise the numerator as well. Sometimes people suggest that factorising is the most simplest form, so you could do that if you want. I guess it doesn't really matter. I don't think they would be that worried whether it was factorised or not, just as long as you've cancelled out any common factors. So, yeah, either of these two answers would be fine. Okay, so now we have a subtract one, but not only do we have one fraction and then an actual whole number, minus 1. So express 2x minus 1 over x plus 9 and then minus 1 as a single fraction. So how do I incorporate a whole number into a fraction? Well, what I would do is, because we know when we subtract fractions, we know how to do that, I would make that 1, first of all, into a fraction. Any whole number, if you want to make it into a fraction, you just put it over 1. I know 1 over 1 is kind of looks stupid, but yeah, that's still the same as 1, isn't it? If I did 1 divided by 1, I still get 1. But I'm kind of reversing it. I want to make it into a fraction. So if you have a whole number, just put that number divided by 1. That's the fraction. Now, obviously, I know that I do need to have common denominators, though. So if I multiply together those denominators, I actually obviously just get x plus 9, don't I? X plus 9 times 1 is x plus 9. So that first fraction can stay the same, luckily. Minus the second fraction, I need to make it x plus 9 as the denominator. So I'm going to times the bottom by x plus 9, times the top by x plus 9. Because it was 1, obviously it's just 1 times x plus 9 is x plus 9. So I've now converted this. Originally it was a 1, now it's this fraction. That's still 1, because if I were to simplify that, x plus 9 divided by itself is still 1, isn't it? Now we can carry on as we did with the previous questions, just subtract the numerators this time. Remember, we're subtracting. So I would probably write it like this, 2x minus 1, subtract, and then put the other one in brackets, because I don't want you to forget. Obviously, it's quite easy to go, yeah, I need to subtract the x, but don't add the 9. We're actually subtracting 9, aren't we, as well? So I tend to write it in brackets just for that step there, so I don't forget to subtract not only the x, but also the 9. So now I'm going to subtract. So 2x minus x is obviously just like 1x. Minus 1, take away 9, is then minus 10. okay? Minus 10, we're not adding the 9, we're taking it away. And then it's over x plus 9. You check, can I simplify this fraction at all? No, there's no common factors between all 4 terms, so that is just it. That's my answer. I've incorporated the 1 as a whole number into that fraction. Okay, now we're looking at divide. These ones look really scary because they are massive, but one thing is I think divide it's not the hardest operation. I think subtract and add are the hardest ones. Divide is easy again, as long as you remember how to divide fractions, then it's fine. The other part is the fact that we've got these 2 quadratics here. This fraction is massive. So we are incorporating a lot more of the part 1 video now. So we've got express 2 over x plus 3 divided by x squared plus 2x minus 35 over x squared plus 10x plus 21 as a single fraction. As with, I guess, all of these questions, you've kind of got a few options as to where to start. You could start by doing the divide, or you could start by simplifying the fractions, as we did in part 1, which is basically where we factorise everything possible, and then dividing. I think I'm going to do that. I would prefer, it's a personal choice, but I would prefer to factorise everything, see what happens, and then I'll apply the divide. So the first fraction, there's nothing I can factorise. Divide. The second fraction, though, I've got 2 complete quadratics, so I know that I can factorise both of those. So if I factorise the numerator, I should get x plus 7, x minus 5. The denominator, I should get x plus 7, x plus 3. Now, before I even go and actually divide, I can already see that I've got 2 x plus 7s, so I'm going to cancel those. And then it's already a little bit more simple to look at. We've got 2 over x plus 3 still. Divide x minus 5, x plus 3. So it's already looking a little bit nicer. As I said, you can divide it first if you want and then simplify, but either way you're going to have to do both of those things. You're going to have to simplify and divide, whichever order you like. Now I'm going to divide it. So divide, we normally use the acronym keep, flip, change. So keep the first fraction, so that's 2 over x plus 3. Flip means flip the second fraction, it always has to be the second one. Upside down, so that's x plus 3 over x minus 5 now. Change means change to multiply. And as we saw in the first question, we know that multiplying, we just multiply straight across, so we get 2 times x plus 3, and then x plus 3 times x minus 5. Now in this case, I know that obviously the numerator is quite easy to expand, but I'm actually not going to. I just wrote it like this. Leave everything as factorised as possible in these questions, because again, I'm still looking to see if I can simplify further. Do you see how now the numerator and the denominator both have x plus 3? If I'd have expanded that numerator, I probably wouldn't have seen that, or I would have just had to refactorise it again. So I like to keep everything in brackets if I can. So then I'm left with 2 at the top and then x minus 5 at the bottom. So not only is it a single fraction, but I've now simplified it as much as possible. There's nothing else I can do to simplify that. So that's my answer. 2 over x minus 5. So for these ones, don't stress about it. Just remember I need to do KFC and I also need to factorise. Those are kind of the 2 things I need to do. Which order you do it in, that's completely up to you. Okay, very similar one again, just a bit longer basically. So I'm going to deal with this in exactly the same way as I just said. So we've got express 2x squared minus 7x minus 4 over 6x squared plus 13x plus 5 divided by x cubed minus 2x squared minus 8x over 3x plus 5 as a single fraction. The other thing you might have noticed is we've got an x cubed. So you might be thinking, how am I supposed to factorise that? I don't know how to factorise anything but quadratics. We'll look at that in a second. Let's just go through one at a time. So I'm going to try and factorise everything that can possibly be factorised, basically. Again, if you want to go through how to factorise quadratics, then I'll link the videos down below as well, so you can recap that. So the numerator, we've got 2x plus 1, x minus 4. Denominator, we've got 3x plus 5, 2x plus 1. Then divide by the second fraction. Now the denominator can't be factorised, so that's fine. The numerator, however, yeah, again, you might be thinking, I don't know how to factorise a cubic expression. That's fine, we're not going to be using 3 brackets. Can you see how all 3 terms have x? So actually in this case, and this is what often happens with GCSE, if you do see something with x cubed and you need to factorise it, a lot of the time it's just pulling out an x. So if I pull out the x, you see how I then get left with x squared minus 2x minus 8. So actually it is just a quadratic, but they've multiplied it by x. Then this quadratic I can now factorize into 2 brackets. So I'm just going to write it here again. So I've got x and x, plus and a minus. There we go. X plus 2, x minus 4, and then just an x on the outside. So I factorised everything. Check, can I already cancel anything out? Well, in the first fraction I can. 2x plus 1, so that simplifies. So I'm going to rewrite that first fraction. I'm going to now apply my divide to bring together both fractions. So my first fraction is now x minus 4 over 3x plus 5. Keep flip change, so that becomes multiply. We get 3x plus 5 at the top now, and x brackets x plus 2, x minus 4 on the bottom. And multiplying straight across, again, don't expand anything, just leave it all in brackets. So the numerator will be x minus 4 brackets 3x plus 5 over, just leave that x at the front there, 3x plus 5 in a bracket, x plus 2 still in a bracket, and the other x minus 4 still in a bracket. Okay, can I cancel out any of the other brackets now? Yes, we've got x minus 4. We've also got 3x plus 5. Now, we've cancelled out the whole of the numerator. So a lot of people would think, oh yeah, it's just whatever's left in the denominator. But remember, those are still in the denominator, okay? So even though I've cancelled stuff out of the numerator, I still have to have a 1 there. It doesn't just disappear. If it were the other way around, if I cancelled out the denominator, then yeah, there's no fraction anymore, is there? But I am still dividing something by x brackets x plus 2. So it's actually 1 at the top there that's left, okay? In this case, that's my answer. I'm not going to bother expanding it, just leave it like that. We've got 1 over x brackets x plus 2. That's the most simplified I can get. Okay, so you can see the routine. We're just factorising, then applying, in this case, divide, and just cancel out as many brackets as you can find. Okay, so our last question is, again, looks even worse. We've got not only divide, we also have a plus and a whole number here. So for this one, what I'm going to do is I'm going to just leave the 5 there for now. I'm going to deal with this divide bit first. Okay, just as we've done in the past 2 questions. So leave your 5 there. Now, the other thing is that x minus 2 isn't a fraction either. So again, just put it over 1. Any whole number or just anything that's obviously not a fraction, put it over 1 to start with. I'm going to keep flip change and then factorise. So I've got x minus 7 at the top, and then this is a quadratic. Obviously, I can factorise that. That's now going to be the denominator. So I'm skipping through a few steps here just to save some space. Okay, so factorise that. We're going to get minus 2 and minus 9. Now I can multiply straight across. Again, just leave the 5 there for now. We'll come back to that. So numerator, again, don't expand it, just leave them in brackets. So x minus 2, x minus 7. And the denominator is just times by 1, so that's still the same, isn't it? X minus 2, x minus 9. Okay, so before I deal with anything else, can I simplify this fraction? Well, yeah, do you see I've got both x minus 2's? Cancel those out. So that's already made it look a lot nicer. Now I can open my square bracket, so I've got x minus 7 over x minus 9. So we've dealt with the divide. Now we're back to that other question where we had just plus a whole number. Again, any whole number, to make it into a fraction, just put it over 1. So we've actually got 5 over 1 plus x minus 7 over x minus 9. Again, we need a common denominator, so multiply the 2 denominators. Luckily in this case, that one's 1. So I just need to do 5 times by the new denominator over the new denominator, and then the second fraction can stay the same because it already has that x minus 9 denominator. Now I can just add them. So add the numerators. I'm going to expand that bracket as well, so 5x minus 45 plus x minus 7 all over x minus 9. Okay, we've got a single fraction. I'm just going to keep collecting the like terms and see what I can simplify. So 5x plus x is 6x, minus 45 minus 7 is minus 52 over x minus 9. I've collected the like terms, but can I simplify anything? Do they have any letters or numbers in common, all 4 of these terms? Actually, no, they don't. That's the most simplified answer I can get. I can't actually simplify that any further. So I've got it as a single fraction. Again, just deal with it step by step. In this case, if you want to go with BIDMAS, we've got the brackets first, so I dealt with divide first, then dealt with the 5 afterwards. So that's all the different possible questions we can get for express as a single fraction. The last part of algebraic fractions is then solving equations with algebraic fractions. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.